given a polynomial, now we need to determine the leading term and in behavior of the graph of the function. So a leading term as a square cube 4, so this is leading term. So let me answer here. So leading term is 3x to the 4th, positive and even. So and behavior, so positive means both up or both down. Sorry, it's even, this 4, even exponent means both up or both down, both sides, but 3 is positive, so it will be both up. All that means in behavior, so increases without bound. Okay, increases without bound in both ends. Okay, eventually in the right side is going up and same in the left side. In B, find the x and y intercepts of the function. So let's find y intercept, because there will be only one y intercept. For we plug in x0, so fx is y, so y equals 0 plus plug in x equals 0 minus 0, or just 0. That means the graph of the function passes through 0, 0. Now x intercept, for x intercept we take y0, that means function 0. So 0 equals 3x to the 4th plus 9x cubed minus 30x squared. So in the right hand side we can factor something. We need to solve for x. So we got x to the 4th, that means there will be 4 zeros counting multiplicities. So in the right side 3 divides 9, 30, so 3 is out, can be factored out. X 4, x cube, x squared, so x squared out, 3x squared out. I'm going to write equals 0 in the right side. First 3 out, x to the 4th, x squared, so x squared left, plus 3 out, so 3 divides 9, 3 times 3, x cube, x squared, just x, minus 3 divides 30, 10 times x squared, just 10. Now we need to factor this. Okay, so 3x squared out. Here this is a quadratic trinomial, so it factors as a product of two binomials. So x squared means x times x, 10, negative 10, and we have to get 3, so 5 times 2, 10, plus 5, because we have to get plus 3, minus 2. Okay, so 3x squared times quantity x plus 5 times quantity x minus 2. So this implies x equals 3x squared 0. Now we divide by 3, take a square root, so x is 0. So 3x squared equals 0 means x 0. X plus 5 equals 0. Subtract 5 from both sides, so negative 5. X minus 2 equals 0, so add 2, so we got 2. So we got 3 x intercepts. Okay, 0, negative 5, 2. In part C, determine the zeros of the function. That means where the graph of the function intersects or touches the x-axis and their multiplicity. So we have already found here. I mean, these are the zeros and their multiplicity, and use this information to determine whether the graph crosses or touches the x-axis at its x-intercept. So x equals 0. If we go back here, we got x squared. So x equals 0, in fact it comes 2 times. So multiplicity 2. Okay, multiplicity 2. When multiplicity is an even, like 2, 4, 6, then the graph just touches the x-axis. Okay, graph the x-axis. Now -5, looking at these factors, we got only one. There is only one, so the multiplicity is 1. So -5, ax equals -5, multiplicity is 1. That means the graph intersects, okay, crosses the x-axis. Graph crosses the x-axis. Same thing for 2. Ax equals 2, multiplicity 1, and graph crosses the x-axis. Okay. Now based on this, we need to draw a graph. In fact, it will be a rough sketch of the function. So here are coordinate axes, and we saw in part A that the graph increases in both sides eventually. So I don't know, but eventually it goes up as well. I don't know what happens in the middle. So we need to figure out at x equals 0, so x-intercept here, so graph touches, in this case touches the x-axis. At -5, -1, 2, 3, 4, -5 here, the graph crosses the x-axis here. And x equals to 1, 2, the graph crosses as well. And eventually it goes up on both sides, increases on both sides. Okay, and it goes from here, it touches, so we have to come here and cross. Same thing here. So let me make it slightly better than this, because we need to cross at 2, something like this. Then it touches this, so then it has to go touch, come back here, and something like this. Okay, now it intersects, crosses at -5 and 2, and touches at 0. Okay, final.